Der Ozean ist höher als die Stadt, denn die Stadt liegt in einer Senke. Dieser Ozean steht 7 m über diesem Mann. Eine einzige Mauer trennt sie. 26% dieses Landes müssten eigentlich längst unter Wasser stehen. 17 Millionen Menschen leben dort. Wie dem auch sei, diese Straße stand 1953 3 Meter unter Wasser. Heute schiebt eine Mutter dort einen Kinderwagen. Moment, dieses Schiff fährt über der Autobahn. Und rechtlich hat das Schiff Vorfahrt. Wie? 9 Kilometer Stahl und Beton, die die Nordsee zurückhalten, gebaut zu einer Zeit, als Computer ganze Räume füllten. 2 Arme, breiter als der Eiffelturm, bewegen sich. Niemand steuert sie. Niemand. Sie haben das Meer nicht nur aufgehalten. Sie haben hineingegriffen und eine ganze Provinz mit Schaufeln herausgezogen. Willkommen zurück bei Next Gen Manufacturing. Die Nordsee ist ein Trichter. Jeder Sturm rast direkt auf die Niederlande zu. Immer. Am 31. Januar 1953 bildet sich südlich von Island ein Sturm. Er nimmt direkten Kurs auf die Niederlande. Um 4 Uhr morgens brechen die Deiche. Die Dörfer schlafen. 1836 von ihnen wachen nie wieder auf. 150.000 Hektar in einer Nacht unter Wasser. Ein Dorf verliert noch vor der Morgendämmerung 305 Menschen. Ein Bürgermeister befiehlt einem Kapitän, sein Schiff in einen bröckelnden Deich zu rammen. 3 Millionen gerettet. 17 Tage nach der Flut sagt die niederländische Regierung, nie wieder. Diesmal mit einem Plan. Er hatte sie 20 Jahre lang gewarnt. Sie ignorierten jeden Bericht. Er starb, bevor sie auf ihn hörten. Jetzt kommt der verrückte Teil, die Küstenlinie um 700 Kilometer verkürzen, mit Bauwerken, die es noch nie zuvor gab. Der Plan war unmöglich. Schritt 1: Errichte eine 32 Kilometer lange Mauer quer durch die offene, wilde See. Eine schnurgerade Mauer, 32 Kilometer. Auf der einen Seite die Nordsee, auf der anderen ein zahmer See. Cornelis Lely hatte eine Idee: schließe die gesamte Zuiderzee mit einem einzigen Damm. Sie nannten ihn wahnsinnig. 10.000 Arbeiter, 27 Schwimmbagger, 4 gleichzeitige Baustellen, die von der Mitte des Meeres aus nach außen bauen, den Meeresboden absaugen und aufschütten. 36 Millionen Kubikmeter, offene See, geflochtene Weidenmatten, die zuerst auf den Grund gesenkt werden. Ohne sie treibt der Lehm einfach davon. Weg. Der Schiffsbohrwurm fraß das ganze Fundament von innen auf. Hohles Holz, korrodierender Stahl. Die Basis ist zerstört. Verrottetes Holz wird durch Baryt ersetzt. Es lacht über Salzwasser. Neubau im Winter, mitten im Meer. Basalt, härtestes Vulkangestein, von Hand auf die Stirnseite geschichtet. Hier endet die Nordsee. Noch 50 m. Die Tide läuft mit 5 Knoten. Eine einzige Chance, ihn für immer zu schließen. Sie warten auf Stillwasser, den einen Moment, in dem die The scene described as the monumental closure of the Zuiderzee, a defining moment in Dutch hydrological engineering that began with the completion of the Afsluitdijk in 1932. That single 32-kilometer barrier turned a volatile inland sea into a lake, the Meer, instantly shutting off tidal influence and creating the conditions for the largest land reclamation project in human history. The window of tidal pause, slack water, was the only chance to dump boulder clay and sand from barges into the narrowing gap, fighting the fierce currents of the Wadden Sea until the final breach was sealed. Behind that dam, which sits 90 meters wide at its base, the North Sea has been pressing for nearly a century, yet it was never enough merely to exclude the sea. The Dutch wanted the seabed itself. The province they speak of is Flevoland, entirely drawn from the water. In 1940, the area that would become the Noordostpolder and later eastern and southern Flevoland was still open water or shallow sea. A ring dike was built to enclose a target area, and then the long, patient process of dewatering began. Massive pumping stations, 3 of them originally constructed for the Noordostpolder, running continuously since 1942, drained the lake centimeter by centimeter. As the water level dropped, a primordial mud boundary emerged, revealing a seabed that had not seen air since the end of the last ice age, some 10,000 years ago. That desolate, lunar-looking expanse, cracked and sterile, was not colonized by human hands at first. Engineers understood that the exposed marine clay, saturated and anaerobic, needed desiccation and structure before it could support crops. So they waited, and the wind brought common reed, an airborne pioneer, which established itself naturally across the drying flats. The reed transpired vast quantities of water, its roots cracked the soil, and its decay built the first organic layer, precisely as plant, a deliberate alliance with ecological succession to turn a sterile seabed into arable earth. Today that same ground lies up to 5 meters below sea level, a landscape of rigid orthogonal plots, drainage ditches that flow 24 hours a day, and tractors crossing fields that the previous year were part of a lake. The relentless removal of water, however, caused the land to sink as the clay compacted. The engineers had traded one problem for another. So they designed a regime of controlled drainage, maintaining enough soil moisture to prevent excessive shrinkage and oxidation of peat layers, effectively managing subsidence by not letting the ground fully dry. This required constant, unbroken vigilance. Pump stations never stop. If they halted, Flevoland would flood. The human order imposed on this reclaimed seabed was absolute. Roads were laid out before houses existed, farms were surveyed and assigned before a single occupant moved in, a new society geometrically projected onto the blank floor of the former sea. A whole city, Lelystad, was planned on paper while the Polder floor was still submerged, then built to completion with an exactitude born of limitless control. But history violently interrupted the narrative. In 1945, retreating German forces flooded the freshly reclaimed Meer and parts of the unfinished Nordostpolder, turning them back into a bitter inland sea. The Dutch, having no alternative, simply drained them a second time, reclaiming the same land twice and demonstrating that the engineered landscape was now as much a product of political will as of water management. Every lesson learned in this first phase, the behavior of soft Holocene clays under dewatering, the design of ring dikes and canal systems, the art of managing a polder's water table against its own tendency to sink, was scaled up massively to complete the rest of Flevoland. The final pumping station at the Eiselmeer's southern shore, the diesel-driven Wortman station, joined the others in the ceaseless elimination of water, and by 1968 southern Flevoland was dry. The coast had, however, been struck with catastrophic flooding in 1953 in the southwestern delta, which forced the nation to entirely rethink sea defense. The knowledge gained from closing the Zuiderzee fed directly into the delta works, where the Dutch once again exploited the tidal window of slack water, but with a new technique. Enormous hollow concrete caissons were constructed on land in dry docks, then floated to site, precisely positioned, and sunk to form instant breakwaters and dam segments. The scene of the 5,000-ton caisson floating out as dock gates open and water rushes in is the direct descendant of the Afsluitdix barge dumped clay. It was repeated 13 times along the Dutch coastline, from the Hollands IJssel barrier to the eastern Scheldt storm surge barrier, each caisson a reusable piece of land built and sunk at the sea's own rhythm. In all of this, the deep narrative is one of a nation that moved beyond merely resisting nature to methodically taking the sea floor, orchestrating the emergence of a province out of mud, and then applying the resulting hydraulic mastery to a monumental coastal fortress while never forgetting that the land they created would forever require the hum of pumps, the discipline of controlled seepage, and a continuous, vigilant pact with the water they expelled. Mehr hinaus. Sehen Sie. Jetzt könnte man denken, einfach versenken. 4 Schlepper, die gegen die Tide kämpfen, widersprechen. Schwierig. Sehr schwierig. Doch es gab ein massives Problem. Die Strömung lässt den Senkkasten rotieren, unkontrollierbar trudeln. Sehen Sie genau hin. Vorab gesetzte Anker auf dem Meeresboden. Stahlseile stoppen die Drehung. Er sinkt gerade. Stahlkabel über eine offene Flussmündung. Hängende Steinkörbe, die Tonnen von Schüttgut in eine reißende Strömung kippen. Hier ist der verrückte Teil. Das Abdichten der Meeresarme zerstört jedes Lebewesen darin. Lasst das Wasser fließen. Haltet es offen. Haltet es offen. Da trafen sie eine verrückte Entscheidung. Verwerft es. Fangt von vorne an. 10 Jahre. 2,4 Milliarden $. Jeder Damm ist schneller als der vorherige. Beim letzten, Tage, nicht Wochen. Nichts würde überleben. Das sagt ein Muschelzüchter, wenn man ihn nach der geschlossenen Dammvariante fragt. Massive Dämme. Fertig. Eine 9 Kilometer breite Lücke bleibt. Zweimal täglich peitscht die See hindurch. Die massiven Dämme sind fertig. Jetzt der Albtraum. Bewegliche Stahltore über 9 Kilometer offene See. Ein 42 m hohes Stahltor senkt sich ins Meer. 75 Minuten, bis der Ozean versiegelt ist. 65 Pfeiler, 62 Stahltore. Offen bei Ruhe, geschlossen bei Sturm. So etwas hatte noch nie jemand. The next chapter in the Dutch campaign against the sea materialized in the Eastern Scheldt, where the initial plan to dam the estuary outright was abandoned in favor of a storm surge barrier that could preserve the tidal ecosystem while still protecting Zeeland from catastrophic flooding. To build it, engineers created an artificial island from scratch in the middle of a violent tidal estuary, a factory isle named Neeltje Jans, and on it they began casting the 65 colossal concrete piers that would form the skeleton of the barrier. Each pier required a month to pour, a cycle that repeated continuously for 5 years, with climbing formwork inching upward as the concrete below hardened, ensuring the monolithic structures grew without pausing. Their guide rails for the steel gates cast into the concrete with a precision measured in millimeters on that man-made island surrounded by churning seawater. The seafloor itself had to be prepared with superhuman accuracy. 2 ships, purpose-built for this project alone and never used again, each capable of lifting 20,000 tons, deployed 5,500-ton concrete mattresses onto the seabed at depths of 30 meters, positioning every single one within 20 centimeters of its target. With the bed dressed, the same floating shear legs lowered their own decks, a fully cured pier was floated over them, and then the ship lifted 18,000 tons of concrete with only GPS guidance, holding it within a 20 centimeter tolerance before lowering it onto that precisely placed mattress far below the surface. At one critical moment, the entire scheme nearly collapsed. A 15 metre wide cavity was discovered beneath a pier foundation, a miscalculation that could have caused the structure to fail. In a desperate corrective maneuver, grout was pumped through pipes into the void while sensors confirmed the growing solidity, and only once the material set did the pier settle safely, a crisis averted by the narrowest of margins. With the piers in place, the 62 steel gates, each 42 meters wide and weighing 480 tons, were hung between them by a floating crane, threaded into concrete guides with just 50 millimeters of clearance on either side. Each gate is an autonomous machine, a single motor drives a spindle, with no external power cables, so that if the central operating system fails, the gate can still be closed manually. On 4 October 1986, Queen Beatrix gave the command, and all 62 gates dropped simultaneously, closing off 9 kilometers of estuary in 75 minutes and sealing Zeeland behind a wall of concrete and steel designed to absorb the fury of storm surges while leaving the tides to breathe. For 38 years the barrier has stood, its hydraulics aging, maintenance crews working while the sea never rests, and roughly 30 times the gates have been closed in anger, each time, the sea lost. Yet Rotterdam faced a deadlier threat requiring a machine that did not yet exist. The busiest port in Europe could not be permanently closed off like an inland sea, it had to be sealed within hours when a storm surge approached, and then reopened immediately to allow shipping. 6 years of engineering produced the Maaslankering, a creature of floating geometry that begins with an alarm, the opening of dock lock gates, and 2 enormous arms, each heavier than the Eiffel Tower, beginning to move. The solution was deceptively simple. Hollow steel gates float out of dry docks on opposite banks, swing toward each other across the busiest shipping lane on the continent, fill with water, and sink to the riverbed, sealing the port. To make this possible, 2 concrete pits were excavated deep into the opposing banks of the Nieuwe Waterweg, and in 1991 a continuous concrete platform was cast directly across Europe's most crowded river, with ships sailing over it the entire time. The floating gates themselves are 210 meters of welded steel that must remain buoyant when pumped dry and then sink obediently on command, one after the other, pivoting on 237-meter steel trusses that convert the ballast operation into a precise, gravity-driven choreography. Each ton of the structure, the hollow chambers, the truss arms, the ball joint foundations serves a single task: to transform the turbulent energy of a North Sea storm into the measured descent of a movable dam, closing the gate on the sea without ever closing the gate on the port. Nordseekraft auf einen einzigen Punkt übertragen. Die größten Kugelgelenke der Welt, hergestellt in Tschechien. Einmal eingebaut. Nur ein Versuch. 10 Meter Durchmesser, 680 Tonnen Stahl. Es erlaubt einem 6,800 Tonnen schweren Arm, völlig frei zu schwingen. Das Docktor öffnet sich. Der Fluss strömt herein. 6.800 Tonnen Stahl beginnen zu schwimmen. Das erste Mal, dass das Tor schwimmt, 340 mm schief auf einer 210 m langen Struktur. Das ist katastrophal. 26 innere Kammern, jede regulierbar. Ballast so lange umverteilt, bis der Trim über 210 m nur noch 15 mm. You asked for a deeper expansion of that exact passage, so here it is, woven into a single flowing paragraph without headings. The philosophical transformation of Dutch water management finds its most autonomous expression in the Maeslandkering's computer brain, the Beslis, an Ondersteunensystem Stroomvloedkering, universally known as BOSS, which requires no button, no human confirmation, and no political authorization to seal the most heavily trafficked port in Europe. The system constantly ingests real-time data from tide gauges, wind stations, and river discharge monitors, running predictive models of North Sea surge propagation, and when the water level at the Hook of Holland is forecast to exceed 3 meters above normal Amsterdam level, a threshold set at precisely 3:0 meters NAP, BOSS autonomously declares a closure event, a decision that human operators can override but never initiate, because the Dutch learned that delay kills. Once the threshold is tripped, BOSS commands the dry docks to flood, the lock gates to open, and the two hollow steel sector gates, each 210 meters long and 22 meters high, to begin their synchronized 180-meter swing across the Nieuwe Waterweg on ball joints embedded in bankside foundations that each anchor a 237 Metre triangular truss arm. 2 hours after the prediction crosses 3 meters, with no hand on any lever, 6,800 tons of steel settle onto the dredged riverbed sill, the gates flood with water, and Rotterdam's Europort, the gateway for 300 million tons of cargo annually, is sealed tighter than a submarine hatch. The North Sea, which for a millennium dictated the fate of the Low Countries, has finally encountered a machine that anticipates its moves, calculates closure hydrodynamics faster than a human committee can convene, and acts with absolute algorithmic certainty. The system proved itself in November 2007 during the storm known as Tilo, when BOSS triggered its first genuine closure under combat conditions. A northerly gale combined with a spring tide pushed the surge to threatening levels. The gates swung, settled, and locked. Rotterdam remained perfectly dry while the surrounding coast absorbed the assault, and 6 hours later, as the surge subsided, ballast pumps emptied the gates, the trusses drew them back into their concrete berths, and the voids. Busiest ships resumed their passages as if the entire operation had been a rehearsal. Yet that immense steel mechanism, the largest moving structure on Earth, could only protect the Rienemeuse Delta's economic heart, small towns and villages along narrower but equally critical waterways, places like Kampen on the IJssel or the settlements clustered behind the Ramsdiep, could never afford such a leviathan, and they required an entirely different philosophy of barrier, one that was invisible when not needed, rapidly deployable, and affordable. The answer emerged from a radical rethinking of materiality, a rubber dam that lies dormant on the riverbed and rises from beneath the water only when called. At Ramspol, where a single watercourse funnels a storm surge from the IJsselmeer toward the ancient city of Kampen and 110,000 inhabitants of the surrounding polders, the waterway was simultaneously too wide for a conventional steel gate and too vital to leave without a permanent defense. Engineers installed 3 parallel inflatable rubber Kevlar bladders, each only 2 centimeters thick, fabricated from multiple layers of vulcanized rubber reinforced with Kevlar aramid fabric, the same material used in bulletproof vests, flat and nearly invisible on the concreted riverbed, hidden from every boater and every casual eye looking down from the IJssel Bridge. The bladders were tested to destruction at a specialized facility before a single meter was laid. They were overinflated until explosive failure, and only after the prototypes withstood pressures far beyond any conceivable storm were the production units fabricated and bolted to the sill. When a storm alarm is triggered, air compressors, housed in strange low structures on the riverbanks that were deliberately shaped to resemble armadillos, armoriet, dome-like shells with overlapping concrete scales protecting the machinery that sustains life within, force compressed air through redundant pipe networks into the 3 flat bladders. 30 minutes after activation, 3 cylindrical black shapes begin to break the surface, water sheeting off their expanding forms. 1 hour, and a continuous, 10-meter-tall flexible wall spans the entire width of the 260 Metre crossing, requiring no crane, no swinging gate, no monumental steel truss, only the primal force of pressurized air. During the critical storm that validated the Ramsbokering's design, the water on the seaward side surged to 9.1 meters above NEP while the inflated barrier held firm at 8.2 meters, leaving only 900 millimeters, the length of a newborn baby, between protection and a catastrophic overtopping that would have sent a cascade into the streets of Kampen. That razor-thin margin was secured by intentionally engineered redundancy. Every solenoid valve has a parallel backup. Secondary air supply lines ensure that a single rupture never depressurizes the system. And fiber optic strain sensors embedded in the rubber measure elongation in real time, feeding data to operators who monitor the membrane's integrity as it flexes under the weight of a storm. The triple bladder geometry was designed so that if one bladder were to be punctured by debris, the other two would rise slightly higher under increased pressure and maintain the seal, a guarantee of survival built into the geometry itself. The Ramsbokering helped that night, but it also taught the engineers a deeper, more uncomfortable lesson that reshaped every subsequent project. A rigid barrier, whether steel or rubber, forces water to pile up elsewhere, accelerating currents, eroding banks, and simply displacing the threat rather than extinguishing it. This realization forced the ultimate strategic reversal. Instead of fighting the water, they had to let it in, deliberately, on their own terms. That insight gave birth to the sand motor, the sand engine, the most audacious act of surrender-as strategy ever attempted in coastal engineering. In 2011, along the Delfland coast between Hoek van Holland and Scheveningen, an area chronically eroded by the strong longshore drift that sweeps sand northward, the engineers made a single, massive intervention and then walked away. They dredged 21,5 million cubic meters of sand from far offshore and sculpted it into a hooked peninsula, a lagoon-shaped spit extending more than a kilometer into the sea, with a sweeping curve designed to mimic nature's own depositional forms. The old method of beach nourishment required returning every 4 years to pump more sand onto the shore, a perpetual treadmill of diesel, dredges, and disturbance. The sand engine inverted this: place enough sand for 2 decades in a single deposit, then allow the wind, waves, and tidal currents, the very forces that had been the enemy for centuries, to do the work of distribution for free, forever. Since 2011, the North Sea has been moving millions of tons of sand every single day without human intervention, grain by grain, shifting it along the coast, building new dune fields, widening beaches kilometers downdrift, and spreading the protective sediment exactly where the models predicted, a self-maintaining landscape still evolving at this moment, its sandy contours migrating slowly while biologists catalog the colonization by dune grasses, seals, and shorebirds that were never part of the engineering specification. The same logic, once proven on the coast, was turned inland toward the rivers, where a parallel program known as Ruimte voor de rivière, room for the river, fundamentally rejected the old dogma of ever higher dikes in favor of lowering the land next to the river to give floodwater a safe place to go. At Viesenwapenveld, on the east bank of the IJssel, engineers excavated a brand new 9-kilometer-long flood channel straight through productive farmland, a sinuous secondary riverbed bounded by low summer dikes but designed to carry a vast volume of water during winter high flows. The channel's inlet and outlet are controlled by simple earth thresholds, so that when the IJssel rises above a set level, water. When the IJssel River rises to the designated trigger level, the water simply spills over an unremarkable earthen sill at the upstream entrance of the Viesenwapenveld bypass and pours into the 9-kilometer-long secondary channel, a floodway excavated straight through what was once productive dairy pasture, requiring no mechanical intervention whatsoever, no pumps to start, no gates to swing, no rubber bladders to inflate, no steel trusses to pivot because the entire mechanism is gravity and Topographie, a surrender of land orchestrated so that water makes its own choice to leave the main stem. That single new river arm, a sinuous depression lined with rough grassland and crossed by farm bridges standing on stilts above the seasonal flood, lowers the high water peak at the vulnerable downstream reach by precisely 27 centimeters. In hydraulic terms, a hand's breadth is not trivial, it is the threshold between containment and Katastrophe, the slender margin that keeps the water from kissing the underside of dike crests and instead holds it well below the danger zone, preventing the kind of overtopping that scours the inner slope and triggers a full breach. When each of the 30 projects in the Room for the River program contributes its own modest reduction, a few centimeters here from a lowered groin, a decimeter there from a widened floodplain, the cumulative effect of those 27 centimeters, multiplied across the entire delta, represents not just safety for Deventer and Zwolle but the hard-won assurance that a repeat of the near disaster of 1995, when 250,000 people were evacuated in panic as dikes trembled, will never again bring the nation to the edge of catastrophe. Some of the interventions were even more disarmingly simple: a beach placed in front of an existing dike along the lower IJssel, nothing more than trucked in sand imported from the North Sea bed and sculpted into a gently sloping foreshore. Absorbs the deep water wave energy through the natural turbulence of breaking surf and percolation into the pore spaces of the sand grains, so that by the time the Waffes remains reach the dike's basalt revetment, their destructive force has been bled away into harmless slosh, and the dike behind it, which for decades had borne the full brunt of every storm, now feels nothing, a quiet retirement of a hard structure cushioned by a soft one. The Programme's 30 integrated projects, stretching from the German border to the North Sea estuaries, form a single coherent national act of landscape surgery. On the Val near Nijmegen, the engineers lowered a series of stone groins that had pinched the river for 2 centuries, reducing their height so that floodwater spills smoothly over them, spreading out across an expanded floodplain and dropping the water level by critical centimeters, simultaneously. They excavated a brand new side channel at the Lentbent, moving the main dike 350 meters inland and creating an elongated island that now hosts a river park and thousands of new homes, a project that combined flood safety with urban regeneration in a single Gesture. In the Noordwaardpolder, just upstream of the Holland's deep estuary, the most radical act of depoldering in Dutch history involved breaching the outer dike in multiple locations and transforming an entire 4,450 hectare polder of former agricultural land into a deliberate flood storage basin. A freshwater tidal wetland where Rhine water now flows in and out with the tide twice daily, absorbing storm surges that would otherwise race down the narrow channels toward Rotterdam, while within seasons of the first deliberate flooding of the Noordwaardpolder, the landscape that had been rigidly partitioned into rectangular agricultural plots for half a century dissolved into a mosaic of open water, mudflats, and reed beds, and the speed of the ecological response stunned even the project ecologists. Spoonbills arrived first, their spatulate bill sifting the brackish shallows for sticklebacks and shrimp that had instantly colonized the newly tidal creeks, while great egrets stalked the flooded grasslands with the slow precision of creatures that had been waiting for exactly this invitation. Within 3 years, a breeding pair of white-tailed sea eagles, Haliaeetus albicilla, the largest raptor in Europe, with a wingspan that can exceed 2.5 meters, built an eyrie in a dead oak on the edge of the new wetland and successfully fledged young. The first such breeding record in the Western Netherlands in living memory, a biological affirmation that surrendering land to water is not loss but transformation. The Overdiep's polder on the Maas took an entirely different philosophical path, one that refused to pit human habitation against flood storage in a zero-sum contest. Instead of buying out the dairy farmers and erasing a working community to make room for the river, the engineers of Rijkswaterstaat proposed lifting the farmsteads themselves, reconstructing each one atop a purpose-raised earthen mount, a modern terp, directly echoing the artificial dwelling hills that the Frisian and Groningen inhabitants had built in the first millennium to survive in a landscape without dikes. The outer dike of the Overdiep's polder was not breached but deliberately lowered along its entire length, a calculated reduction in height that allows the Maas, when swollen with winter rain and snowmelt from the Ardennes, to spill over gently and fill the entire polder like a bathtub, submerging the grazing pastures under 1.5 meters of silty brown water while the 8 elevated farmsteads, each connected by a narrow raised access road, remain dry islands in a temporary inland sea. The cows, long accustomed to the slow rise of water, continue to graze on the uppermost slopes of the terps until the flood peaks and then recedes, leaving behind a thin, fertile layer of river silt on the pasture. Exactly the natural fertilization process that sustained the flood meadows of pre-industrial Europe. This is a medieval solution reborn in the 21st century with all the analytical power of modern hydraulic engineering. The terps were sized using the same computational fluid dynamics models that once calculated the optimal closure sequence of the eastern Scheldt barrier. Their crest height set with sub-centimeter precision to remain above the 1 in 10,000 year flood level, their internal drainage designed to prevent seepage into the living quarters, and their access roads engineered to remain passable to emergency vehicles even as the surrounding polder disappears beneath a sheet of water. The Overdiep's intervention is not an isolated experiment but a note in the systematically connected array of 30 separate projects that constitute room for the river, each one calibrated by the same lineage of hydraulic models, Vaqua, Delft 3D, Sobeck, that descend in a direct intellectual line from the analog computations used by Cornelis Lely to plan the closure of the Zuiderzee nearly a century earlier. On the IJssel floodplain near Deventer, the removal of obstacles was literal: brick factory ruins, abandoned ferry ramps, and a grove of hybrid poplars that had been planted for the matchstick industry were all excavated and cleared. lowering the floodplain roughness coefficient just enough to shave another few centimeters off the design water level. At the Haringvlietsluises, the great discharge gates that had slammed shut against the sea since 1971 were, after decades of ecological campaigning, ordered to stand permanently ajar, reopening the Rienemoise estuary to tidal exchange, allowing migratory fish, salmon, sea trout, sturgeon, to pass upstream for the first time in over 40 years, and reducing the bottleneck that caused floodwaters to stack up against the closed gates during combined river flood and North Sea surge events. Each centimeter of flood peak reduction achieved by one project was fed back into the basin-wide model, reducing the required dike height at the next vulnerable reach, so that the program as a whole traded 1,000 individual small surrenders for a systemic security that no amount of concrete could have bought alone. The philosophical arc that began with the Zuiderzee closure in 1932, the moment when the final gap in the Afsluitdijk was sealed and the North Sea was permanently expelled from a vast inland basin, has now completed its revolution. The Afsluitdijk itself is 32 kilometers long, its base 90 meters wide on the seafloor, armored on the Wadensee site with Norwegian granite blocks each weighing several tons, a monument of exclusion that took 5 years of continuous dumping from barges working the tidal windows of slack water. That same determined society, which then ring-diked and pumped dry 1,650 square kilometers of that enclosed sea to create the province of Flevoland, where the pumping stations have run without interruption since 1942 because if they halt the land returns to the lake, now sends surveyors out to mark dike sections for deliberate breaching. The land that was won from the seabed by the centimeter, using the transpiration of wind-sown reed to crack the anaerobic clay, is being given back, not in defeat but in a strategic recalculation of value. The engineers who once solved the near-catastrophic 15-meter white cavity beneath an eastern scaled pier foundation by pumping grout under sensor feedback, who threaded 480-ton steel gates with 50 millimeters of clearance into concrete guides, who built the autonomous computer boss that seals Rotterdam without a human pressing a button, have taken that same precision, that same refusal to accept failure, and applied it to the careful orchestration of letting water in. The Noordwaardwetland, the Overdiep's Terps, the Lowered Groins, the reopened Haringvliet, each is a calculated aperture in a living machine that breathes rather than resists. The nation that watched its grandparents haul boulder clay in freezing rain to close the final tidal gap, that endured the German flooding of the Meer in 1945 and simply drained it a second time because there was no alternative, now understands that the alternative was always there. Hidden in the very physics of water, a wall escalates forces, raising the water level upstream, accelerating currents, demanding ever greater countermeasures in a spiral of hardening, while an invitation dissipates energy, spreads it across floodplains, and uses the landscape's own morphology to absorb the shock. The 1995 near evacuation of 250,000 people from the river region, when dikes saturated with weeks of rain began to bulge and crack under the pressure of a Rhine swollen by unprecedented snowmelt, broke the national faith in ever higher walls and opened the political space for this philosophical reversal. The Dutch have come to see that the enemy is not the water itself but the rigidity with which it is met. The guest, properly welcomed, deposits sediment, recharges aquifers, and creates the shifting habitats on which spoonbills and sea eagles depend, and then, as the storm passes and the tidal cycle turns, it drains patiently back to the sea through the same breaches it entered, leaving behind a landscape renewed rather than devastated. This is not an abandonment of engineering but its ultimate triumph, the wisdom to know when a pump must run forever and when a dike must be lowered, when to hold the line with 18,000-ton caissons and when to step back and let the current do the work for free. Because across a century of unimaginable ambition the Dutch have learned that the water will enter one way or another, and the only enduring choice, the only truly sustainable defense for a country where 60% of the population lives below sea level, is whether to meet it with a wall that must grow higher with every passing decade or with an invitation that transforms the ancient adversary into a collaborator in the continuous remaking of the land. Hochwassersicherheit erhöht von einer zu 1250 auf einen zu 2000 Jahren für den gesamten Rhein. Jede Barriere lehrte die nächste. 90 Jahre Ingenieurskunst. Jedes Projekt lernt vom vorherigen. Sie bauten ihr Überleben. Jetzt verkaufen sie das Wissen an jedes Land, das das Meer bedroht. Januar 2023. Der Sturmpier löst den Marslandkehring aus, der sich erst zum zweiten Mal überhaupt schließt. Alle Barrieren schließen gleichzeitig, koordiniert von einem einzigen System, erbaut von einer einzigen Generation von Ingenieuren. Keine Todesfälle durch Hochwasser seit 1953. Nicht, weil die Stürme aufgehört hätten, sondern weil die Niederländer etwas zwischen sich und sie gebaut haben. Sie haben eine Festung gegen den Ozean gebaut. Das Wasser ist immer da, wartet immer.